Hello everybody, in this video we are going to be looking at calculating dosages. So to start us off, I want you to take a look at this question. Through trial and error, you discover that you need an average of 190 milligrams of caffeine a day to function at your best. If there are about 95 milligrams of caffeine in each cup of coffee, how many cups of coffee should you drink a day, a week, or a year in order to be functioning at your best? So I want you to pause the video here and try this out, and then when you're ready, start the video back up. Okay, so if you need 190 milligrams of caffeine a day, and there's 95 milligrams of caffeine in each cup, let's take a look at 190 milligrams divided by 95 milligrams gives you 2 cups of coffee, okay, in order to get to your 190 milligrams a day. So that means you need 2 cups of coffee per day. So how do I figure out how many in a week? Well, we can multiply this by 7 days in a week, which gives us 14 cups per week. And then with that same kind of thought process, we can times that by 52 weeks in a year, which gives us 728 cups in a year. So if you look through our thought process here, and you may have solved this a completely different way, and that's fine, we had to kind of figure out how many cups of coffee would get us to the amount we needed in a day. And then we multiplied that up to get a week, and then multiplied to get a year. We can use that same thought process when we are doing dosage calculations. So if you think of the 95 milligrams of caffeine in each cup of coffee as the strength of a medication, the amount of medication in a tablet, let's say, or in a milliliter, and 190 milligrams of caffeine as what the doctor has ordered, then you can figure out, well, how much do we need per dose, how much per day, for the course of a treatment, and so on. So we can use the same sort of thought process when doing calculating dosages. So like I said, there's tons of different ways to solve this out, and if you have a method that is working for you and gets you to the correct answer, that is perfectly fine. I am going to be using ratio and proportion for this so that I can be consistent. And to keep with the consistency, I'm going to set it up so I have what is available on one side, or like the strength of the medication, so they equal to what is ordered or what the patient needs. Okay, so let's take a look at this first question. So a medication has a dosage strength of 15 milligrams per 1 milliliter. Think of that like how much caffeine in a cup of coffee. If the patient requires an order of 45 milligrams, how many milliliters must you administer? So let's go back through and fill out our available to ordered ratio and proportion. So what is available? Well, the dosage strength that we have is 15 milligrams per 1 milliliter. The patient requires, so we're ordering 45 milligrams. How many milliliters is that? So I'm going to put an X there, or you can put a question mark or what have you, because that's what we're looking for. Now, a few things I want you to notice in this setup. One is that I have the available on one side, so the 15 milligrams per milliliter is on one side of the equation, and the ordered is on the other. The other is that I also lined up the units, so I have milligrams on top and milliliters on the bottom. Now, if you set it up the other way, you put milliliters on the top, milligrams on the bottom, that's perfectly fine. You will get the correct answer, but you have to be consistent. So I kept the available on one side, the ordered on the other, and my units are lined up. Once you have the ratio and proportion set up correctly, The rest of the math is the same regardless of the question. Setting it up is the hard part. It's the trickiest part. Once you get it set up, you're going to follow a very kind of structured procedure for each time, regardless of what the original question was asking. So what I'm going to do is I'm going to cross multiply, which means I'm multiplying across the diagonals. So I get 15 times x, which gives me 15x, and 45 times 1, which gives me 45. Now I want to get the x by itself. I want it to be x equals something. And right now I have 15 times an x. So I'm going to divide both sides by 15 so that the x gets by itself. I've canceled out the 15s, and I end up with x equals 3 milliliters. Okay, so I can look back up, see my x was milliliters. The original question was asking how many milliliters must you administer, and the answer is you must administer 3 milliliters. We always want to end with our units in a sentence attached. Okay. The other thing you might come across is that you have differing units. You always want to do the question in the same units, and usually we like to do that in the units of the available medication and what the tablets or the grams or whatever the medication comes in. We want to do it in what that equals to, so that we're staying consistent with what our final answer will end up being. So in this one, it says a client is to receive 0.625 grams of medication. The tablets available to you are 125 milligrams. So how many tablets does the client require? Okay, so let's write this out into our ratio formula. So what's available? Well, the tablets available to us are 125 milligrams for 1 tablet. And the ordered medication is 0.625 grams. So let's take that aside for a second. 0.625 grams. If we look at our metric conversion scale, we have grams, decigrams, centigrams, milligrams. So to get from grams to milligrams, I'm timesing by 10, 1, 2, 3 times. So 1, 2, 3 times is 625 milligrams. So the client needs to receive 625 milligrams, and they want to know how many tablets is that. Again, you'll notice I have available on one side, ordered on one side, milligrams on the top, tablets on the bottom. And now we're going to do our cross multiplication. So I get 125x equals 625. And then I want to get the x by itself. So I'm going to divide by 125, and I get x equals 5 tablets. So therefore, the client requires 5 tablets. Now, in the next lesson, we're going to be talking about more types of medications. We're going to be looking at the rules when it comes to administering medications, and you'll find out that you're not actually supposed to give 5 tablets for a dose. What that's telling us is that we need a stronger tablet, because you really shouldn't be giving more than 3 tablets for at one sitting. So next lesson we'll look into all these rules, and the following question will be, is that safe? Should you actually be administering it like that? So some things that you will need to be aware of is some different medical abbreviations. So BID means twice a day, B standing for bi. TID is 3 times a day for try, and QID or quad is 4 times a day. You may also see Q and then a number H. Q2H, for example, is every 2 hours, every 4 hours, every 6 hours, every 8 hours, and so on. So you may see a number in between a Q and an H, and that stands for how many hours in between each dose. PO means by mouth, and PRN means as needed. Now there's a ton of different medical abbreviations, so make sure you are familiarizing yourself with all of these. You can find them in chapter 11 of the course textbook, or it's also on the front cover as well. Okay, so let's look at how to solve these types of calculations when we're given sort of an order, a prescription, and then looking at what is available to us. Okay, so on order, we have lithium citrate in an oral solution, meaning that's going to be like a liquid when you see solution. So they need 300 milligrams. PO, again, is by mouth. And TID means 3 times a day. Okay, so they need 300 milligrams by mouth 3 times a day. You have available to you lithium citrate in 300 milligrams per 5 milliliters. Now, some of you can look at this and know right away, okay, well, they need 300 milligrams and it's 300 milligrams per 5 milliliters, so I'm giving them 5 milliliters. So you can definitely just look at this logically and write that out. I'm going to do the ratio proportion just so that you can practice the working out of it, but it wouldn't necessarily be needed in this case. But let's look at available and then ordered. So available to us is 300 milligrams per 5 milliliters, and what is ordered is 300 milligrams how many milliliters. Okay, I'm then going to do cross multiplication, and you get 300x equals 1500, and then we divide each side by 300, and we get x equals 5 milliliters. So therefore, they need 5 milliliters per dose. Again, obviously this is one that we can kind of look at and see, but just to show you how the math would work out, that's how it would look. Okay? So now we need to take that and we need to figure out how much per day. So we looked at per dose, how much per day, and that's where we're looking at the rest of the order there, so the POTID. So by mouth doesn't really matter to us at this moment. 3 times a day, the TID is 3 times a day, so that means I'm going to take my 5 milliliters and times it 3 times a day is 15 milliliters per day. And we could also look at, if they told us for 5 days, then we could look at, over the course of the treatment, they would need, so much for the course of the treatment. Okay, let's look at this one. So we have amoxicillin, 300 milligrams. PO, again, that means by mouth. Every 6 hours, and then for 7 days. Okay, available to us. Here's a picture. We need to be able to look at this and see the different things that we need. So we're looking for the strength of the medication. So a lot of people will see this 100 milliliters and think, that's the strength. That's not the strength. That is how much of the medication is in this container. So that is not what we're looking for. We're looking for how much amoxicillin is in each milliliter, or in a certain amount of milliliters. And you'll see that written right here and right here as well. Okay, so what this says is it's 125 milligrams in 5 milliliters of the oral suspension. Okay. So how many milliliters must be administered per dose? Let's look at our available to ordered. So available to us is 125 milligrams in 5 milliliters. And what is ordered is 300 milligrams. And we want to know how many milliliters. So I'm going to do my cross multiplication, and I get 125x equals 1500. And then I'm going to divide each side by 125. And I get x equals 12 milliliters. So therefore, they need 12 milliliters per dose. We always want to kind of look back. Does this kind of make sense for the question? Well, there's 125 milligrams in 5 milliliters, and I need 300 milligrams, which is more than double. So I know I'm going to need more than double the milliliters as well. So you always want to look back. Does this number make sense? Right? If my number went down, it was less than 5 milliliters, and I know I set up my ratio wrong because I know they need more than that in order to get what was ordered. The next part of this question is how many milliliters must be administered per day. Well, in this one, it doesn't give us how many per day. The previous one said 3 times a day. This one says every 6 hours. So what we're going to do is do 24 divided by 6 gives us 4 times per day. Okay, so in a 24-hour period, if it's every 6 hours, they're going to take it 4 times a day. So now we're going to do our 12 milliliters times 4, and we get 48 milliliters per day. And then it says how many milliliters will have been administered by the end of the treatment. Well, if we look up at the order, it was for 7 days. So I'm going to do 48 milliliters a day times 7 days gives me 336 milliliters by the end of treatment. Okay. So again, I'm going to take what is available, set it equal to what is ordered, and solve it out, and that will give me how much per dose. And then I'm going to use the rest of the order form here, so it said every 6 hours in this one, to figure out how many times per day, and I'm multiplying that up, and then again multiplying by the number of days to find the end of the treatment. Okay, so here is some more on the screen. I want you to try number 1 and 2 on your own, pause the video, and then start it up again when you're ready. Okay, let's look at number 1. We have an order of 10,000 units subcut of medication, and it's available at 7,500 units per milliliter, and again it wants to know how many milliliters per dose. So we're going to set it up as available to ordered. So available to us is 7,500 units over 1 milliliter, and then ordered is 10,000 units, and we want to know how many milliliters. So now we are going to cross multiply, and we get 7,500x equals 10,000. And then to get the x by itself, we're going to divide by 7,500. And we get x equals 1.33 repeated milliliters. And again, next lesson, we're going to be looking at safe practices. So you would look at how to round this number and whether rounding this number is safe. Okay, so for right now, we'll just leave it at 1.33 milliliters. Okay, number 2 says that there is 3/4 of a grain of medication, and the tablets are labeled as 90 milligrams, and that's what available. So again, we have a differing number of units here, a different unit, so we need to make sure that we are converting this to the same unit, to available and ordered. So available to us is 90 milligrams per tablet. And we're going to set that equal to what is ordered. And right now for ordered, we have 3/4 of a grain. And our unit is 1 grain is 65 milligrams. So to do that conversion, I'm setting up my conversion rate as a ratio, and I'm multiplying it so that the grain is on the top and on the bottom. There's lots of different ways to do conversions. In this one, I'm trying to cancel out the units. So I'm going to take 3/4 and multiply by 65. Is 48.75 milligrams. I'm going to take that whole number, no rounding, and I want to figure out how many tablets that is. I'm going to cross multiply. And I get 90x equals 48.75. And then divide by 90, I get x equals 0.54166 repeated. We're going to round this to half a tablet. Again, we're going to look at rounding rules and whether that is an appropriate rounding in this situation, but for now we're just going to leave it at half a tablet. Okay, last one here. I want you to pause the video, try this one out, and then start up the video again when you're ready. You're looking at per dose, per day, and for the course of the treatment. Okay, so ordered is a morphine sulfate, 6 milligrams subcut, which means that it's going to be used in an IV. Q4H means every 4 hours. As needed for pain for 3 days. Now, even though it's as needed, you're going to be looking at if they needed it every 4 hours, how much would be basically the most they would get over that time period. Okay, so how much must be administered per dose? Well, again, we're looking at what's available over what's ordered. So let's look at this picture. And again, we're looking for how much of the medication is in a certain amount of milliliters. And if you look, it looks like these are vials, and they each contain 1 milliliter of the morphate sulfate injection. Okay? And 10 milligrams is in each milliliter. And I'm reading that right here. Okay, so the 1 milliliter is just telling us how much is in this vial. That's not a strength, right? The strength is going to be a certain amount of medication per a certain amount of liquid. Okay. So available to us is 10 milligrams per 1 milliliter, and ordered is 6 milligrams. And we want to know how many milliliters is that. So again, we're going to cross multiply, and we get 10x equals 6, and we're going to divide by 10, and we get x equals 0.6 milliliters. Okay, we're not rounding this to 1 milliliter because it's a milliliter, and we can get that in an IV. Unlike up here with tablets, I can't get 0.54 of a tablet, I can get half a tablet. Okay, so to see how many is administered per day, I'm looking at the rest of the order there, and it says every 4 hours. So in a 24-hour period, if it's done every 4 hours, they will get 6 times a day. So I'm going to take my 0.6 times it by 6, and I get 3.6 milliliters per day. And then by the end of the treatment, so this is going on for 3 days, we're going to do 3.6 times 3 equals 10.8 milliliters by the end of treatment.